All right, let's work on 2.1, frequency distributions and their graphs. So we started working a little bit on frequency distributions and tally marks. I think we did that in the developmental section, but let's take it that next step. Okay, so a frequency distribution is a table. It's going to show classes and intervals. That's the tricky part. That's what we have to work on in this section. So it's got classes and intervals in the first column, and then it has the count of how many entries fit in each of those classes or intervals. Okay, and that's where those tally marks come. So the frequency F of a class is the number of data entries in that class. So if we come up here to the class 1 to 5, we have 5 people in that group. So they had a score of anywhere between 1 and 5, including 1 and 5. So it's inclusive. If we come down here to the 16 to 20 group, so whoever scored 16 to 20 inclusive, we call that, because we include the ends, there's 8 people who scored there. Okay, so we do have some other vocabulary we've got to watch here. They will tell you how many classes they want you to set up, and then we go from there. So in this case, let's grab the 16 to 20. So if we come down here and we say 16 to 20 is the class we're looking at. So for us, the lower limit for this one, the lower class limit is the 16. The upper class limit is going to be 20. Okay, so the lower number is our lower class limit. The larger number is the upper class limit. And we are looking for people who have scores anywhere between 16 and 20, including 16 and 20. So they can have 16, they can have 17, 18, 19, and 20. Okay, and then we're going to count how many people have scores between 16 and 20 inclusive. Okay, now the class width, we can't just subtract 20 minus 16. That does not work for the class width. So we've got our class width here. What we have to do is take the lower limits from different classes and subtract those. So let's say I came here and looked at the first 2 classes. So I would take 6 minus 1, which gives me 5. That's the class width. So even if I came down here and looked at the last 2, if I take 26 minus 21, so I'm looking at the lower class limits for each of them, I would also get 5. So for us, our class width is going to stay the same, but it's a little deceiving. We cannot just divide the numbers that are inside the class. We have to look at 2 separate classes. All right, and then we have the range. So the range is what we are going to actually look at the data. So we have to actually see the raw data to find the range. We're going to take the largest number and we're going to subtract the smallest number. So this is just a quick intro. We're going to do some problems together and we're going to put together some flashcards, I think, on here. Otherwise, I'll have the flashcards separate. Nope, there's the flashcards right here. Okay, so for the first one, we're looking at the word frequency. And that is the number of data entries that's in each class or each interval. And we actually tally up the data, and we're going to do that together. Then we have class width. That is the difference between the lower limits of the second class and the first class. So you look at the first 2 intervals, or the first 2 classes, you look at the lower limits, and you subtract those 2. Then we have the range. The range, we have to actually see the raw data. And so we grab the largest number and the smallest number and subtract them, and that's going to give us the range. The lower class limit is the smallest number within the class. So remember, we looked at 16 to 20. So the lower class limit would be 16. The upper class limit would be 20. And we have some flashcards with some examples so that you're not just looking at words. All right, so this is one big giant flashcard. I don't know if it's going to fit on an index card or not, but I gave you 3 different classes here. I gave you 1 to 5, 6 to 10, and 11 to 15. Notice they don't overlap, right? The first one ends at 5, the next one starts at 6. There can't be any overlap with these frequency distributions. Otherwise, we would be confused of where the data would sit. So this says, what is the class width? Okay, so remember, at first, when you're looking at this, you probably want to take 5 minus 1, but that's not going to work. That's not the class width. We have to actually look at two separate classes. So we're going to grab the lower class limit of the second class and the lower class limit of the first class, and we're going to subtract those. So that would give me 6 minus 1, which is 5. And notice, if we're looking at these scores, in the first group, they can have a score of 1, 2, 3, 4, or 5. And so those are actually 5 items in that class. So 5 minus 1 is deceiving because that's only 4. If you count them out, you would see that you actually have 5 elements. Okay, another flashcard. So I gave you some data here. I gave you 7, 11, 4, 13, and 22, and I'm asking you for the range. So what you have to do is you have to find the maximum point of all 6 of those. That would be 22, so the largest point. Then you want to find the minimum point, which is the smallest data point. That would be 4, and then we're going to subtract those. So 22 minus 4 gives me 18. That is the range of my data. All right, so I'm actually going to do the work on the next few pages, but I wanted to show you this. So we have a frequency distribution already set up. We've got the classes on the first row here. We have 15 to 25. These are temperatures, 26 to 36, 37 to 47, and so on. Okay, so they already put our classes together for us. Notice there's no overlap. This one ends at 25, but the next one starts at 26. And then they already tallied the frequencies for us as well. But they're going to want some other information. They want the midpoint, the relative frequency, and the cumulative frequency. We're going to work on those one per page. But I wanted you to see here that we have round to the nearest hundredth, right? So that means 2 decimal places, if needed. All right, so let's work on midpoint. Okay, so this is the same data. We've got our classes and our frequency, and the first thing they want is the midpoint. Now, I'm not going to do all of those, but we'll do a few. So what I'm going to do is take the lower class limit plus the upper class limit divided by 2, because I want to know the midpoint between 15 and 25. So what I'm going to do is add 15 plus 25 divided by 2. So that would be 40 divided by 2, which would give me 20. Okay, so that's my first one. I'm going to make some awful lines here. Let's try the next one. Try to give myself some space here. So this one would be 26 plus 36 divided by 2. Let me see what I've got there. That's 62 divided by 2, and that gives me 31. All right, let's try one more. And then you guys could finish the rest of the chart. You'll actually get to do that in the homework. So here I'm going to take my lower limit is 37 plus my upper limit of 47 divided by 2. That's going to give me 84 divided by 2, which is going to be 42. All right, and then you would keep going. Now, something I wanted to show you here that's kind of interesting is if you look at your class width. Let's come over here and look at our class width. Well, so this is my width. If I take 26 minus 15, I get a class width of 11. So if I take 15 plus 11, I get 26. If I get 26 plus 11, I get 37. 37 plus 11, I get 48, and so on, right? Same thing works for the upper class. 25 plus 11 is 36. 36 plus 11 is 47. But it also works for the midpoints. Look over here. I have 20. If I add the width of 11, I get 31. If I add the width of 11, I get 42, and that would keep working as we filled out that table. All right, so that's midpoint. Okay, next we're going to look at what's called relative frequency. This is going to look at what percentage each of these classes are to the whole. Okay, so we are going to look at the frequency for each class. You have to go line by line, just like we did in the last example, but we need the total. So what I did is I went ahead and put all of these numbers into the calculator. I added up this, what do I have here? 7 numbers from 17 to 21, and I got 365. So that's my sample size. That's my N. We use N to denote sample size. So I added up all the frequencies. That gave me 365. So now I'm going to do a percent. So I want the piece over the total. We're going to say that that's the frequency over the sample size, F over N. So for this first one, I'm going to take the 17, that is the frequency, divide that by 365. And they wanted 2 decimal places because they wanted hundredths. So if I take 17 divided by 365, I get 0.0465. So I'm going to go ahead and round up. And I get 0.05. So this first class makes up about 5% of all of the classes. All right, let's try the next one. So the next one, we want to take the 45 this time. That's the frequency, still divided by my N, 365. Let's see what we get. 0.12328. So I'm going to just go with 0.12. So this class actually makes up about 12% of the total. And we're going to go ahead and do one more, and then I'll let you guys fill out the rest. So the next one, we're going to take the 68, that's the frequency, divided by 365. That gives us 0.1863, so 0.19 if I'm rounding to 2 decimals. Notice the percent's climbing, the decimals are climbing. Well, the frequencies got bigger as well, right? We had 17, we had 45, we had 68, and it's all over the same N, the same sample size. So you guys can go ahead and finish the rest of this in your homework, because you're going to have a problem like this in your homework. Let's go on to the next. Okay, this one's a little trickier until you get the hang of it, and then you'll just whip right through cumulative frequency. So what happens is you're going to look at the row you're in plus everything before it. Okay, so for the cumulative frequency, you're going to look at the row that you're in plus everything before it, and you're going to add up all of those frequencies. Add up frequencies. Okay, so for the first one, if I look at this first row, I only have the first row, right? I don't have any rows before. So we're just going to grab 17 because the current class has 17. I don't have any before that, so I'm good to go. I can stop. Now with the second row though, here I am at the second row. I want the frequency from this row, but I also want the frequency from this row because I want all the previous classes. So I have 45 plus 17. So that's going to give me, what, 60, 62, I think. 4, 5, 6. Yep, I think so. Okay, so that's my cumulative frequency, 62. Let's go to the next one. The next one, I want not only my third row, but I want the rows before. So I have 68 plus 45 plus 17. And that gives me 130. So I'm gonna go ahead and finish these out, but not showing everything. So for this one, I would need the 69 plus everything before. That would get me to 199. Same idea here. I would have 77 plus everything before. That would give me 276, and I'm gonna keep going. And when I'm done, I better get to my 365 or I'm in trouble, which I did. I got to 365. Okay, so each time you're just adding the frequency of that new row, right? When I jumped from 130, the third row down to the fourth row, I added the 69 from that row. When I moved to the next one, I added the 77 from that row and so on. So whichever way works for you. Some people like to add them all up. That works for each row, or some of them like to just work their way down. But with cumulative frequency, you're always looking at the current row and all the rows before, and you want to make sure that your very last number is the same as your sample size.